Welcome back, students. Welcome to this lecture series of your GATE 2027, in which we are covering many of the important topics for the upcoming GATE 2027 and further GATE examinations. And in this highway lecture series, we have covered many important topics in transportation. Actually, transportation comprises of highway and other things. Okay, so in this transportation highway, we can say that we have railway airport also. So we'll see some topics of railway also. In this, one of the most important topics for your GATE examination is cant or super elevation in your railways. Lot of questions, lot of previous questions have been asked from this topic. So we'll be taking this topic and we'll be covering what is cant, what is the equilibrium cant, and then we'll also see cant deficiency, cant excess. All those things we'll cover in this short video. So it's a very important topic. Therefore, I decided that we will be covering this today. So we'll be covering equilibrium cant, cant deficiency, and then cant excess. You can join this Telegram group for getting access to more notes, lectures, guidance, other things. Okay. So we'll be starting with this topic known as what? Cant. Cant, or we can say super elevation. So what is this cant or super elevation? Why we provide this cant and super elevation in railway tracks where it is needed? Okay. So we provide this cant or super elevation on horizontal curves. We provide where? We provide on horizontal curves. So if we have a railway track like this, okay, if we have a railway track like this, and we know that, I'll just draw one, see, a train consists of a lot of wagons and the engine. I'll just draw one wagon, suppose, and drawing a one wagon which is traveling on this curve. So what will happen? Since it is traveling on the curve, what happens? So there will be what? A centrifugal force P, right? There will be a centrifugal force P acting. And due to this centrifugal force, there might be what? Derailment. So to counter this centrifugal force, what we do? We provide this cant. Okay, we provide this cant. And what we do actually? How we provide this cant? This is the outer rail, right? This is the outer rail and this is the inner rail, right? This is the inner rail. So what we do? We raise the outer rail with respect to inner rail. So if I draw here the outer rail, if I draw the outer rail here, you see the rail sections are I sections. So this is the outer rail, and here we have the, suppose, inner rail. So what we do? Okay, the inner rail is looking a little smaller. Okay, it's okay. I'll just redraw this outer rail. This is the inner rail and this is the outer rail. So we raise this outer rail with respect to inner rail. So you can see that there is difference of level, right? You can see that there is difference in level of this outer rail and inner rail. There is difference of level of outer and inner rail, and this level difference is known as what? Cant. So this level difference is known as what? Cant. So level difference between this outer rail and inner rail top. So this is known as what? The cant. The cant. So if you are asking cant or super elevation in case of railways, what is the definition? The definition is, it is the level difference between, the outer rail and inner rail at curve location. It is the level difference between the outer rail and inner rail at curve location. And why it is provided? It is provided to counter the centrifugal force. Okay, it is provided to counter the centrifugal force. Something like this you can see. So what happens? You see, the outer rail is up, the inner rail is down. So what will happen? The train will tilt. The train will not tilt so much. Here I have shown little bit more exaggerated. It will not tilt that much, but it will tilt. So what will happen? You see, This is the centrifugal force. Okay, I'll draw in black or red something. So this is the centrifugal force. This is the centrifugal force. Centrifugal force. So what will happen now? So a component of weight, you see weight is acting like this. So this is the centrifugal force. Now the weight will be acting like this. So now what will happen? I will have a component of this centrifugal force in this direction, and will also have a component of this weight in this direction. You see, I can have this components of this weight acting in this direction perpendicular to the direction of this train. So suppose this is the weight W. Suppose this is the weight W. So this will be W cos theta. This is theta. W cos theta. This is W sin theta. Yes. And then here also this is the centrifugal force P. So this will also have what components? So this is, suppose I can write down this as, suppose P cos theta, and this component will be what? W sin theta, right? So this P cos theta will balance by what? W sin theta, and then there will be what? Equilibrium, right? So to counter this centrifugal force, we are providing this Cant. Now in this we come across the first term, that is known as what? The theoretical Cant. We come across the first point, that is what? Theoretical Cant. So what is this theoretical Cant? I'll write down CTH. This is known as what? The theoretical Cant. This is the theoretical Cant. Theoretical Cant means the Cant required. How much is the Cant required by a train? The Cant required by a train. The Cant required by a train is equal to how much? It is equal to theoretical Cant. The formula is G V square upon 127R. So this is the formula. The theoretical Cant or the Cant required. The theoretical Cant or the Cant required. Now see here in this V is the speed of the train in kilometer per hour. R is the radius of the curve. The curve will have some radius. So this R is the radius of the curve in meter. It is the radius of the curve in meter. Now what happens? This quantity is unitless. This V square by 127R is unitless. So whatever unit you will put for G, you will get the same unit of the Cant required. Now what is this G? Now remember, this G is the dynamic gauge length. Okay, this is the dynamic gauge length. Now what is dynamic gauge length? Dynamic gauge length is, what is the dynamic gauge length? The dynamic gauge length is the center to center distance between two rails. So here in this case, the center to center distance. So if I draw the center to center distance here, you see the center to center distance. This is known as your dynamic gauge length. This is the dynamic gauge length, center to center distance. And the value of dynamic gauge length is how much? The value of dynamic gauge length is, this G is 1750 mm for your broad gauge and your 1058 for meter gauge. Now what happens? Students get confused. What students get confused? Students get confused that they confuse with the gauge length. Now dynamic gauge length is different from your gauge length. What is the gauge length? Gauge length is the clear distance. If you see this is the clear distance. If you see, the clear distance is known as what? Gauge length. So this clear distance is known as gauge length. This clear distance is known as what? Gauge length. And this center to center distance is known as what? Your dynamic gauge length. And in Cant calculation, we don't take the gauge length, we take the dynamic gauge length. Okay. So here, for broad gauge, the gauge length is 1676, but dynamic gauge length is 1750. So we don't take the gauge length, we take what? We take the dynamic gauge length. Similarly, for mg, meter gauge, the gauge length is 1000, but we don't take that. We take what? Dynamic gauge length or center to center distance, that is 1058. So remember this, many students commit this mistake that for broad gauge they take 1676, which is wrong. We should take what? 1750 mm. These all are in mm. Okay. And for meter gauge we take what? Not 1000 but 1058 mm. Okay. This is very important that we take these values into consideration. So remember that in Cant calculation, we don't take the gauge length, means we don't take the clear distance, we take the center to center distance, we take the dynamic gauge length. So in some books or some older notes and some, if you are studying from some other sources, remember that this is wrong. We don't take 1676, we don't take 1000, we take how much? 1750 and 1058. We take these values into consideration. Yes, we took these values into consideration. Now, this is the Cant required. Okay, this is the Cant required. Okay, this is the Cant required. Okay, so this Cant required is for a particular train which is traveling at speed of v km/h. Now what happens on the same track? Different vehicles will be traveling at different speeds, right? All of them will not be traveling at the same speed. So therefore I can say the theoretical Cant or the Cant required for different trains will be different, right? The Cant required for different trains will be different. So I have to go for some value which is fixed. Means what? See, suppose some train will come at 60 km/h, some train will come at 70, some will be 80, some will be 90, some will be more than 100, whatever. So different trains will have different speeds, and therefore the Cant required by them will be different, or the theoretical Cant will be different for different trains. But when we are going for the providing the Cant or the actual Cant, then we need one particular value, right? We cannot keep on changing the Cant as per different trains. So therefore we come with the concept of what? Equilibrium speed. We come with the concept of what? Your equilibrium speed. What is this equilibrium speed? This equilibrium speed VE is sort of what? It is the average speed. It is sort of what? The average speed. So average speed. And how we calculate this equilibrium speed? We find out this equilibrium speed by using the formula summation of NIVI divided by summation of what? NI. Now what are this NI and VI? Very easy. You see, so suppose we have N1 trains traveling at speed of N1 trains traveling with speed of V1, and suppose we have N2 trains traveling at speed of V2. Similarly, Nn trains like this continues, like N3, N4, N5, Nn trains traveling at a speed of Vn. So what are these things? These things are frequency, right? These things are frequency. And this thing is the speeds, right? This thing is the speed. The speed. So I can say this N are the frequencies of trains traveling at different speeds. So what I will do, summation of NIBI means what? N1 V1 plus N2 V2, N3 V3 dot plus Nn Vn divided by what? Summation of this frequency. Summation of frequency will give me what? This is indirectly total number of trains, right? Summation of frequency will give me what? Total number of trains. So by using this formula, I can find out what? I can find out the equilibrium speed, which is sort of what? The average speed, which is sort of the average speed. So now when I am providing the Cant, okay, so when I am going for the Cant provided, this Cant provided is also what? The actual Cant, right? This Cant provided also the actual Cant, and is also known as what? The equilibrium Cant. It is also known as what? Equilibrium Cant. Why? Because this is provided as per equilibrium speed. Since it is provided as per the equilibrium speed, so we also call this as what? Your equilibrium Cant. So actual Cant or Cant provided, Ca I will write down. So this will be equal to what? G, same equation. In place of V, we'll use what? Equilibrium speed. So same formula, just in place of V, it will be what? Ve. So if I repeat it again, so what we saw that this is the theoretical Cant, or I can say the Cant required. And the Cant required depends on the speed of the train. So about different speeds, we will have different Cant requirements. Okay. So this is the Cant required. So that will be different for different trains. But we cannot provide different Cants for different trains. When we are providing the Cant, we have to provide a single one, right? So what we do, we find out equilibrium speed. So this equilibrium speed is sort of what? Average speed. And by using this formula, we can find out the equilibrium speed and the actual Cant. So when I am providing the actual Cant, it is as per the equilibrium speed. It is as per the equilibrium speed. Okay. So let us solve a few questions asked in GATE. So this question was asked in GATE 26 recently. This year only they asked this question. And this question was an MSQ. This was an MSQ questions, means more than one option correct. What is written? Cant C on a broad gauge, so BG, broad gauge, railway track is calculated for an equilibrium speed of V. So here the equilibrium speed is given V. Okay, so notation can vary, right? Somebody can write VE, somebody can write V, okay, what? So equilibrium speed is given here V. And dynamic gauge, I have told we use dynamic gauge, and radius of the curve R. So which formula we use, they have asked. Now, first of all, this is the formula. So option A is correct. This is the formula. Option A is correct. GV square by 127R. That is the formula. Just now we saw. The equilibrium Cant is what? GVE square by 127R. And they have, in place of equilibrium speed, we use the notation VE. They have used V. So they can use different notation. That is always fine. So since equilibrium speed they have given V, so GV square by 127R. So that is correct. So this is correct. Now, so we saw that this is the formula. Now we know that G value is how much? G value is 1750 mm, right? We take dynamic gauge, we don't take gauge length. So we will not take 1676. Okay? We will not take 1676, we will take how much? 1750. So when we take this 1750, then what happens? So this changes to 1750 into your V square by 127R. So when you use this, this becomes 1750 divided by 127. We are getting a value of, you see, approximately 13.78 V square by R, which is close to option B. Okay, which is close to option B. Now they have given the other options to confuse. So if you are taking 1676, if you are taking wrongly taking 1676, so how much value you are getting? So you are taking 1676, so you are getting around 13.2. So this option is given just to confuse the students. This is wrong option, right? Because this 13.2 is derived as per 1676. So this is wrong. So this is also wrong. This is not correct, right? And if you see the last option, this 8.3, this will get as per, if I am doing for mg. See, if I am doing for mg, I'll use what? 1058. So 1058 V square by 127 R. So if you are using this will become 1058 divided by 127. I am getting a value of 8.33. So this last equation which I am getting, it is correct equation, but this equation is for what? This equation is for mg curve. So for bg curve I can say this is valid, and obviously this equation is coming from this equation, so this is also correct. Now this is wrong because this is for mg curve and this is all total wrong. So right options are A and B. So you can see very easy question, very easy question. Let us solve another question which was asked in GATE. Let us solve another question which was asked in GATE. So I already explained to you equilibrium Cant, okay. What I told, equilibrium Cant, how we are finding this equilibrium Cant. This equilibrium Cant is the actual Cant, and how we are finding? G VE square upon 127 R, and this equilibrium speed how I am finding? By using this formula NI VI divided by summation of NI, okay. So let us solve one question which was asked in GATE on equilibrium Cant. You can see what is given is the number of trains and their corresponding speeds on a curved broad gauge section is given to us, okay, and radius is given, you see, your 437. So radius is given, broad gauge is given, means G becomes equal to how much? 1750, okay, this becomes equal to 1750. Now these are the trains, frequencies and speeds are given, okay, and what is asked? We have to find out the equilibrium Cant, and they have told to round up to the nearest integer. Now if I want to find out the equilibrium Cant, what I have to do? First I have to find out the equilibrium speed. So how I can find out the equilibrium speed? Equilibrium speed will be equal to, you see, this is what? These are the frequencies N, and these are what? The speeds. So N1 B1 plus N2 B2 plus N3 B3, N4 B4, N5 B5. So I can do this. 20 into 40 will give me how much? 800. So 20 into 40 gives me 800, plus 15 into 50 will give me how much? 750. Then 12 into 60 will give me how much? 720, plus 8 into 70 will give me 560, plus 3 into 80 will give me 240. Now this whole thing divided by the total number of trains. Total number of trains, how I can find out? By adding all these frequencies. So 20 plus 15, 35, plus 12, 47, plus 8, 55, plus 3, 58. Or I can go reverse. 11, 33, 48, no, wait. 11, 23, 38, 58. So total number of trains is 58. So if you calculate this equilibrium speed, so how much equilibrium speed I am getting? Let me calculate this. So 800 plus 750 plus 720 plus 560 plus 240, whatever I am getting, I'll divide by 58. I am getting the equilibrium speed as 52.93 kilometer per hour. There are kilometer per hour. Now you can easily find out the equilibrium Cant is the actual Cant. So I can use this formula G V square divided by 127 R. So if I am using this formula, very easy. G, we know it is 1750 for broad gauge. Equilibrium speed we have just calculated, 52.93 square divided by 127. Radius is how much? Radius is 437 given in the question. So we are finding this, you see, 1750 into 52.93 divided by 127 divided by 437. Okay, I'll just recalculate the value. 1750 into 52.93 square divided by 127 divided by 437. I am getting 88.34. This value I am getting how much? 88.34 mm. Now what is mentioned in the question? Round to the nearest integer. So nearest integer is 88. So we'll mention the answer as 88. So pretty simple question, okay? Pretty simple question, okay? Pretty simple question. So such kind of questions will going to be asked in the examination, and we just saw, I'll just revise and then we'll go to the next topic. We just saw that that this is the theoretical Cant, means the Cant required. It is GV square by 127R. Then we saw the actual Cant, or the equilibrium Cant, is what? It is GV square divided by what? 127R. And equilibrium speed, how we determine this equilibrium speed? It is summation of frequencies into the speed divided by summation of frequency. In this manner, we can find out what? Whatever they're asking, we can always find out that. Let us go to the next concept, that is known as what? The Cant deficiency. Now, what is this Cant deficiency and Cant excess? What is the concept of Cant deficiency and this Cant excess? Let us study that. Okay. So, you see in this question, what happened? If you see this question, in this question, you see the equilibrium speed we got is 52.93. Now see this trains traveling at 40 km per hour, this train traveling at 50 km per hour. So you see these speeds are less than equilibrium speed, right? If you see here, equilibrium speed we have got 52.93, and these trains traveling at 40 km per hour or 50 km per hour, they are traveling at a speed less than this equilibrium speed. At the same time, we have, you see, these trains 60, 70, 80 km per hour. So these trains are traveling at a speed more than equilibrium speed. Yes. So I can say for these trains, speed is less than equilibrium speed, and for these trains, speed is more than equilibrium speed. That means when I am finding the equilibrium speed, there will be some trains which will be traveling at a speed more than equilibrium speed, and there will be some trains which will be traveling at speed less than equilibrium speed. Both things can happen. So suppose we have a train which is traveling at a speed more than the equilibrium speed. So if you have a train traveling at a speed more than equilibrium speed, what will happen? You see here. So V is more than VE. So V square will be more than VE square. And then if I multiply G by 127 both sides, G by 127R, so G V square by 127R will be more than G VE square by 127. So you can see, again I'll repeat, if a train is traveling at a speed more than equilibrium speed, so V will be more than V, so V square will be more than V square. So this relation will be there. Now what is this? This is the theoretical Cant. And what is this? This is the actual Cant. Or I can say this is the Cant provided. Okay, this is the Cant provided, and this is the Cant required. This is the Cant required. So what happened, you see, when the speed is more than equilibrium speed, the Cant required became more than the Cant provided. Means what? Whatever requirement is there, that is more, and we are providing less. Yes, whatever requirement is there, that requirement is more and we are providing less. This requirement is more and we are providing less. So this is what? Deficiency. What is deficiency? Suppose we have protein deficiency or we have vitamin deficiency. What is the meaning of that? The meaning is that requirement is more and we are providing less. Right? Similarly, here the Cant requirement is more and providing less. So in this case, there is what? Cant deficiency. We have what? Cant deficiency, and this Cant deficiency becomes equal to how much? It will be equal to the requirement minus provided. It will be equal to what? Simply the requirement minus provided. Okay. So, and this will be normally occurring in what? In fast moving trains, we observe this, right? In fast moving trains, we'll observe this. Why? Because for fast moving trains, what will happen? The speed of the train will be more than the equilibrium speed. Yes, and there what happens? The Cant required will be more than Cant provided. Yes, Cant required will be more than Cant provided. So that means what? There is deficiency. There is deficiency. How? Because requirement is more and we are providing less. And how much deficiency is there? The amount of deficiency is how much? How much is required minus how much is provided. So this is the concept of what? Cant deficiency. Now, what will be the concept of Cant excess? It will be just the opposite. Opposite means what? If the speed is less than equilibrium speed, means what? In slow moving trains. Okay. See, in fast moving trains, what happened? Speed is more than equilibrium speed. In slow, what will happen? It will be less. So this is less. So what will happen? B square will be less than VE square. If I multiply G by 127R, so G B square by 127R will be less than G V square by 127R. So in this case, what happened, you see, in this case, what is happening, you see, this is the Cant provided or the actual Cant, right? This is the Cant provided or actual Cant, right? And this is the Cant required or the theoretical Cant. Here the provided become more, right? You see, in the previous case, what was happening? When speed was more, see, in the previous case, when speed was more, then what was happening? Requirement is more than provided. But when the speed is less, the requirement is less than provided. So when there is requirement is less and we are providing more, requirement is less, we are providing more, that means what? There is excess. So here what happened? There is Cant excess. And how much excess? And how much excess? That will be equal to this Cant provided or the actual Cant minus this theoretical Cant or Cant required. Just the opposite. So this is the concept of what? Cant excess. So let us compare both of them. So Cant deficiency comes when? Cant deficiency comes when the speed is more for fast moving trains. So speed is more than equilibrium speed and Cant excess, speed is less than your equilibrium speed. Okay. And you can see in Cant deficiency what happened? Requirement is more, provided is less. So requirement is more, provided is less. That means more is required, you have provided less. Indirectly means there is deficiency. How much deficiency? Requirement minus provided. Very easy. And when the speed is less for slow moving, what happened? The opposite happened. Requirement is less, provided is more. So when you are providing more, indirectly means what? We are providing more means, I can say that you have got excess. And what is the excess? That is provided minus required. Very easy. Now there is limits for these things. So these are the limits, right? So there is limit for the Cant provided or actual Cant. There is limit for your Cant deficiency, which is maximum Cant deficiency. Yes, and there is limit for your Cant excess, that is maximum Cant excess. So this can be asked in the examination. You should remember that. See, actual Cant was what? What was the formula? That is GVE square by 127R. So it has a maximum value. What is the maximum value? The maximum value is 165 mm for broad gauge, and for meter gauge it is 90 mm. Like, see, suppose when you are solving this question, you see, solving this question, how much we got Cant, you see, the actual Cant we got is how much? The equilibrium Cant is actual Cant, we got, you see, 88 mm, okay, which was less than 165, right? You see, this is the maximum amount, 165, less than that, okay. So this is the, these are the maximum limits, of the actual Cant or equilibrium Cant or the Cant provided. This is the maximum limit for the actual Cant or the Cant provided or the equilibrium Cant. Now this is the maximum for the Cant deficiency. So the maximum value of Cant deficiency for BG depends on the speed. If the speed is less than equal to 100 km per hour, we take the maximum value of Cant deficiency as 75. And if the speed is more than 100, we take the value of maximum Cant deficiency as 100 mm. Okay. And for meter gauge, we take the maximum Cant deficiency as 50. It doesn't depend on the speed, single value. Now coming to Cant excess, maximum value of Cant excess. So that is for BG it is 75 and for MG it is 65. So if you just write down this table again, if we just write down the table again, sorry. So I can say that, you see, actual Cant maximum values are what? Actual Cant maximum values are 165 and 90 mm. All these are in mm. So for BG curve we have 165 and for MG curve we have 90 mm, right? Now this is what? This is the maximum actual Cant or maximum Cant provided. Now we saw that we can have Cant deficiency. Now what is the maximum Cant deficiency which is allowed? Yes, what is the maximum Cant deficiency which is allowed? For BG it depends on the speed. If the speed is less than equal to 100 km per hour, okay, or the speed is more than 100 km per hour, okay. So if the speed is more than 100, less than 100, we take the value as 75 mm. If it is more than 100, we take 100 mm. All these are in mm, right? So see, you see, less than equal to 100, we take the maximum Cant deficiency 75, and for more than 100, we take 100 mm. Now, for mg, it is straightforward 50. There is no speed consideration, right? So this was what? Maximum. This was maximum Cant deficiency. Then we what have? We have maximum Cant excess. The maximum Cant excess is for BG curve, it is straightforward 75. For MG curve, it is straightforward 65. It doesn't depend on the speeds, 75 and 65. Okay, 75 and 65. So that's it. So we covered many important things. First we saw what is Cant, then we saw theoretical Cant. Theoretical Cant was what? It is the Cant required. Then we saw the actual Cant. Actual Cant we are providing for what? Equilibrium speed, right? We are providing for what? Equilibrium speed. And this actual Cant equilibrium speed, how we are calculating? By using this formula, summation of NI/VI divided by summation of NI. Okay. Now, then we saw that when the speed is greater than equilibrium speed, so we have the concept of what? Cant deficiency in that case. Why? Because in that case, the requirement is more, okay, or the theoretical Cant is more and the provided Cant or the actual Cant is less. Yes. Now, when we have the speed less than equilibrium speed, so this is for fast trains, this is for slow trains. In this case, we'll get what? Cant excess. Why? Because the provided will be more or the actual Cant will be more. This will be equal to actual Cant minus the required or the theoretical Cant. Okay, and then we also saw the maximum values. We also saw the maximum values. Okay, so that's it for the lecture. So these are the important points from Cant which they can ask to you in the examination. First we saw the formula of Cant, then we saw what is the theoretical Cant or the Cant required, then we saw what is equilibrium speed and what is the equilibrium Cant or actual Cant or the Cant provided. We solved question also. Then we saw in which cases we get Cant deficiency, in which cases we get Cant excess, what is the concept of Cant deficiency, what is the concept of Cant excess, how we are calculating that, yes, and what are the maximum limits of the actual Cant provided and the theoretical Cant, not actual Cant provided and the Cant deficiency and Cant excess, the maximum limits, that also we saw. Okay, so thank you very much.